Okay, the last thing we're going to look at here is, well, not the last thing, but we looked at the logarithm, so now we're going to look at the exponential function. Again, the logarithms, the natural log in particular, learn it, love it. It's never going to go away. Exponential, learn it, love it. It's never going to go away. For real numbers x, y equals e to the x is equivalent to if you write expx. This is just another notation. So the natural exponential, if you write exp in front of it, that's just a new notation. This is the most common notation, y is equal to e to the x. But I wanted to show that to you because sometimes you see that, where x is equal to the natural log of y. Because as you know, the natural log and the natural exponential cancel each other out. Right? Okay. Now, let's look at some properties. We had some properties of logs. Let's go back and review here some properties of e to the x. Get some algebra going for us. Our first one is if I have e to the x plus y, we can split that up and say e to the x times e to the y, right? Like bases, you can add those exponents. So you can add them and put them together, or you can break them up. It's equal, so both sides are the same. E to the, x minus y. Same thing. I have e to the x, but instead of multiplication, it's division. Right? So, like bases, you can subtract those exponents. If I have e to the x to the p power to a power you multiply. So that's the same thing as e to the xp. Remembering all this stuff, right? Yeah. Okay, so let's keep powering through. Here's number 4. If I have y is equal to e to the natural log of x, right? Remember, we just talked about these being inverses of each other. Then you end up with simply x. If I have y is equal to the natural log here of e to the x, again, you just end up with x. If your e and your natural log are touchy-touchy, that's what I call it, touchy-touchy, they're inside functions of each other, then they're inverse functions. Remember, we just did a whole section on inverse functions. You swap out those x's and y's. If it's an inverse of each other, when you do that composition, they cancel out and you're just left with an x. Ta-da! Here is that example also. They're inverses of each other. Okay. All right, so we got that nice little algebra review there. So check this out. In this section, they give you this, tower. Oh my goodness, sakes alive. Let's try this again. Useful for tower functions in section 7.3, which we'll get there. All right. They put this part in this section. Let me scoot it up here. But it's going to be more useful in this next section for you. But I want to introduce it now. While we're talking about all of our properties, I want to make sure you can determine why b to the x, so I have a base to the x power. How is that equivalent to e x to the natural log of b? All right, think about this for a second. These are equivalent. I have an equal sign there. This is a fact. These are equivalent statements. My question to you is, how do I get there? It's a good question, right? Yeah, I know, thanks. We're going to use our properties. In class, I like for us to mull this over a little bit, but in our video, I'm just going to go with it. Here, I know with logarithmic properties, if I have a coefficient, I can move that up to the exponent, right? So now I have b to the x is equal to e to the natural log of b to the x. And literally, what did we just put up here? E to the natural log of x. E and natural log cancel out, and I'm just left with my inside function, right? Because e and natural log cancel out. So I can look at this. E and natural log cancel out, and b to the x equals b to the x. And that's how it works. Now, I'm telling you right now, E is our best day ever. It's our best day ever. Anytime I'm working with E, that makes it so nice and easy. So if you're going to work with E, right, go for it. It makes our life so much easier. Okay, so there's the algebra behind it. We're going to be looking at our derivatives here next.